Hey, welcome to the Smart World community. I'm Pete Penagor. I'll be taking you through a couple use cases we have here. So Smart World is really the idea of data and the ability to manage data and connect data across many different sources to manage assets, resources, and services within critical infrastructure more efficiently. So we got a couple use cases here that I'll go through, demonstrating a couple different technology threads that we see as being extremely important to both applying to critical infrastructure, but also things that Lockheed typically does on the military side and the space exploration side. So let's take a look. So this first example is the idea of kind of advanced materials and the ability to embed sensors in a bridge. So what we have here is a bridge that's sensing some sort of issue within the structure. We're dispatching drones remotely to assess this. Once the drones have inspected the structure, they've decided that this is actually an issue that needs to be resolved. And that data flow needs to be in a lot of different directions. So not only is it informing the drones to come and do the repairs, but it's also informing the appropriate authorities to maybe close off the bridge, to keep people away from it while these repairs are being made. Next, we got a thread of kind of technology that we'd like to see in deep space exploration. So think when you have a lot of humans in deep space, you need to sustain them. One way to do that is growing your own food in space, and the idea of autonomously doing that is something that can be easily applied down on Earth in cities to support local agriculture. And in the same vein, these techniques can be applied to other existing infrastructure as well. So a big theme here is that we need to build solutions that are brand new, but also build solutions that build on top of existing infrastructure, because you can't just scrape all infrastructure and replace it. So imagine this same concept being applied to agriculture, typical agriculture and farms, telling a farmer with remote sensing from space how exactly they need to water their crops, add fertilizer to really be efficient in what they do. Next, we have a little cybersecurity example. So all this data, if you're doing autonomous or machine learning and AI-based decision making, the data streams that are coming in really need to be secure if you want them to do trusted decision making on top of it. So in these modern times, our infrastructure is becoming more and more targeted by adversaries, so we need to find ways where we can apply that same kind of AI and machine learning to sniff out in a network the malicious bad actors that could be infiltrating it, and autonomously and without human intervention get them out of there before they cause any damage. Next, we have a little example of a manufacturing plant. So one thing that we can do with Earth observation is remotely monitor any sort of industrial application where you might have contaminants going in the water or pollution going into the air, and not only identify that, but track it back to its source. So in this example, another big piece is power and disaggregated power. So this is a little analogous to how we would maybe build a lunar base and the infrastructure on the moon. But here you have a self-contained manufacturing plant that's powering itself. If you're doing that locally, how can you connect that to other areas in the vicinity to both lean on those areas when you need more power, or potentially if you're producing too much power, sell that power to your neighbors? And then in the same vein, if you have issues with your power supply, like natural disasters or maybe major transmission loss that could be detected via remote sensing, how do you adapt quickly to not lose power and to maintain an always-on capacity? So that's the idea here. And then lastly, we have a fully autonomous decision-making concept for building a new facility. And so a lot of concepts here and technology threads are revolving around remote sensing, identifying autonomously where you want to build, what kind of issues you have with building in a certain area. Is the soil too wet? Is it too dry? Are there environmental impacts that need to be considered? And once you do select a site, the ability to command robotics autonomously to build that is obviously extremely powerful and supported heavily by a space layer of communication that is only going to get more powerful in the future. And one last thing that does is allow you to do this remotely. So any sort of space communication layer in most of these examples in a city is acting as something that's building resilience into the system. So there's already existing terrestrial communication infrastructure. This works in parallel with that to just provide that resiliency. And that's all for Smart World. And again, the key piece of information here is that we're using data and connecting that data and lots of different types of data together to do decision making in an automated fashion to really benefit people by managing resources, services, and assets in a city around critical infrastructure more efficiently.